want to show you a better way to do this, and it's going to be built off of the way Lucia did it. Okay, so I want us to do this. Okay, and you're going to need to do some drawing with me. Okay, so if you haven't written down k plus 3 equals 5 already, okay, I want you to write it out. Now I want you to imagine that this guy here, all of these guys actually, I want you to imagine that they're 3. Sorry, not 3. K. That's K. All right. So I'm going to stick him on the board. There you go. There's K. All right. So why don't you draw like a little, a bigger square there. And these individuals here, can never get these apart. Okay. These guys here, each one of these is just worth 1. Is that okay? Here's 1. So here's, I want an individual. There you go. Here's 2. You get the idea. Okay. So over here, I've got K plus, I need 3 of these, right? And you need to draw 3 as well. So I'm going to put these up. Okay. Here we go. Yes, absolutely you do. And thank you, Millie and Sonia, for putting these together for me. All right, there you go. There's my K plus 3. Is that okay? So far, so good. Yeah. What am I going to have the right hand side? I need 5 of these. Let's see. Okay, hold on. Okay, there you go. Right now, I'm going to go after what Lucia said is her method for doing this. Okay, she said I took 3 away from 5. Now, can you see why that works? Let's think about it. Okay. Why would you take 3 away from 5? Well, we want to know what K is, right? We want to find out, we want to solve, we want to get the solution. Okay. So if I take 3 over here, right? If I take 3 away from this, then I should take 3 away from here as well, right?
Yes.
Because if I take 3 from one side, I should take it from the other. Now, you're like, okay, that's still a bit magical to me. I don't buy it, okay? Sure, it ends up on the right solution, but why is that? Okay, well, let me try and sell this to you a little more. This is an equation, right? Something is the same as something else. Okay, so another way of thinking about it is like 2 things that are equal to each other. Now, let me see. I get this on here. So, set of scales. How does a set of scales work? Okay. Well, very simply, if you put something on one side, okay, he goes down because that's heavier. Can you see it? Yeah, you can. I might put it on. I'll leave it on this side. This side is lower because it's heavier, right? But if I put the same thing on the other side, cool. He starts to go back to normal. Okay, eventually after he'll stop moving, let me see if I can do it. If you look really, really closely, right on the front here, you can actually see a pair of triangles, and they should be pointing right to each other. Unfortunately, this scale's a bit old, so it's not the best, but you get the idea. Okay? Now, it balances. Okay, what would this be? What would this mean? What would this mean? As an equation, how would you write that? Well, I've got one of these on both sides, right? So this is saying something not very dramatic. It's saying K equals K. Well, I hope so, right? Now, here's what's interesting, okay? I'm gonna go after this. Okay, let's actually change this equation a bit and get some different numbers on here. Okay, we're going to form an equation off of this. Let's see. Give me a number. Give me a number. How many of these should I put on this side? Not too big. 4? 4. 4 will do. I can do 6 later. Okay. So as you expected, it hits the ground. Of course it hits the ground, right? It's heavier because you've got 4K here, and you just got 1K there. Of course. So what I'm going to do is I'm going to start putting these little guys over on this side, okay? Now you guys can't see all 4 of them, so I'll put them on. Can you see that? There you go. Okay, good. So the question is, well, how many of these am I going to put over here, right? Let's see. Well, I actually know how many I need to put, so I'm going to put them. I should have made you guess, shouldn't I? I could still make you guess. I can still make you guess. I'm balanced.
12. I guess like 28. I think you do get balanced. No, 20 something.
I'm doing a 12.
So how many is there already? What were you doing?
Shall I? Oh, the white one's hard to see. The white one's hard to see. Okay.
I can't see.
Shall I? Let me take them out and I'll put different colours in. I'll put them in so you can count. Can you count?
I can.
How's your counting?
14. Wait, 1, 2, 3.
Is there a white one in there?
16.
No white ones.
16. Okay.
Alright, I count.
Yeah, try it.
Now I'll admit, it's not perfect, but it's close. I think we're going to call it close enough for today, okay? Because we can play this forever and the scales are going to keep on, wobbling around. What have I got? Well, I count 4K on one side, right? 4K. Right. On the other side, my count here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. On the other. Okay? Now, let's just see what happens. For instance, I mean obvious stuff, right? Obvious stuff. If I took one each of these, oh, wrong color, sorry. One each of these. Because I have a set of scales, right? I should be able to add this onto both sides and it should stay balanced, right? It's a set of scales, yeah? If I do something to one side, oh, down it goes, but put it over here, and it works, right? It's still balanced. What equation would correspond to, oh, you can't see it really, can you? What equation would correspond to this? Yeah, here.
4 times 4.
Hold on. What equation corresponds to this? What did I do to both sides? I added one of these guys, right? Did the same to both sides. So it looks to me like I added one to this side. So I added one to this side. What's 16 plus 1? 17. Okay. Now, these equations, they're equivalent to each other, right? They represent the same set of numbers. The important thing I want to get across to you is when you do something to one side, you do it to the other. Is that okay? All right, let me take off that extra one again. What else could I do? Okay. Yeah. Yeah, I could. I totally could. I could add a K over here and a K over here. What equation would that be? How many K's have I got over there? I've got 5 of them, right? 5K. What have I got on the other side? I've got 16 little guys plus a K, right? All of these are equivalent. You do something to one side, you do it to the other. Okay, now, we wanted to find a solution, didn't we? Okay. Now, it just so happens, right, that this is a new set of equations to this one. So, in fact, just so you're not confused, I'm going to rub this guy off. Okay. I want to know, what's 1K? What's 1K? Now, I'll get rid of this extra one over here. So, have a look. Remember, we've been saying, if you do something to one side, you got to do it to the other, right? Okay. So, 4K, that's actually an abbreviation, right? What's an abbreviation for? It's 4 times K, isn't it? Or K times 4, because multiplication is commutative, right? So if I want to get rid of the 4 over here and just get K on its own, I should do the opposite of multiplying by 4, right? What's the opposite of multiplying by 4? Dividing by 4. Is that okay? Yeah? If I divide this side by 4, I should divide the other side by 4 as well. Okay? So watch what happens. I'm going to divide this up. Look, here you go. There's my there's 1/4 of that side, and there's the other 3/4. Is that okay? And here is 1/4 this side and 3/4 of the other. There you go. I've separated them out. So now I can actually do the division. There's a 1/4 left on that side, and there's a 1/4 left on that side. And if I steal a little bit, it balances. So what equation is this? K on one side, and of course on the other side, 4. Does that make sense? So, 4, or K equals 4, is the value that makes this equation work. K equals 4 is, what do we call that? The solution. So we've solved the equation. In summary, whenever you have an equation like this, okay, I want you to picture this guy. I want you to picture a set of scales, okay? Something equals something else, okay? So if we want to get a solution, if we want to solve it, it's like, well, with our previous example, you can guess. Like I asked you to guess before, how many do you think it would take to balance it out, right? That's a very slow method, right? A quicker way is to think, okay, what can I do to both sides that'll keep it even, okay? You know, what we had before was K plus 3, right? There's K plus 3, there. So I would have 7 on this side, wouldn't I? And it would balance. Sorry, I moved it. There you go. That easier to see? K plus 3 here, 7 here, right? So of course, to undo adding 3, right, I would subtract 3, right? Like so. 3 from here, and 3 from here. You've always got to make sure it balances. Does that make sense? Yep. Excellent. Okay.